Let us wait for the recording to start. Okay, so it is finally done. Your classification, this thing, yeah, number of epochs for 8 only. You can reduce number of epochs so that it runs fast. And the batch size is also big. Actually, you can reduce the batch size. In a multiple of 8, you can give 64 will be fine. 256 would be fine. Multiple of 2 rather, not 8. 8-bit 8816, you can go, give them in a multiple of 8 also. Validation split is 0.1. Again, that will take time. And then we are printing the validation loss and the training loss. So you can see that validation loss is going little up, but training loss is going down. So this is a good sign. And you can see that the accuracy is okay. It's not very good, but it's okay. So losses are there. Uh, validation loss is there. So validation loss is increasing. That's why the accuracy is not that good. It depends again on the data set. Then we have training accuracy and validation accuracy. Again, you can see that training accuracy is good, but the validation accuracy is going down. That means when we are testing, we are putting the validation data set, the output is not as desired. Okay, so not a very good output, but anyway, that's okay. Sometimes it happens because of the model or because of the overfitting things. You can reduce the size dimensions, you can reduce, and you can reduce or increase the epochs, but batch size you can reduce, and that should be enough. Dropout also you can change, you can vary the dropout and check with that. I cannot run it now again, it will take more than an hour again. Then it's okay, you can test it, I'll share it, and then you can experiment with the different values. uh, 256 is also big actually. 500, I have taken 512, that's why it is 256. You can reduce that to 64, or 256 is half of that. You can have 64 also. 64 should be enough, and you can change the dropout also and check, and you can reduce the number of epochs so that you can understand how much time it is taking. So it should not take much time if you reduce the epochs, and you can increase the split, validation split also, or decrease it. So you can experiment and see what gives you the better results. Number of epochs you can increase, but then you'll have to change the size. The terms you're giving, you have to reduce that. Okay, so Lstm model looks like something like this. Have input, then this is the process and the output, and it is explained here also, and you can have a look at the uh, details at this link. You can have a look at the details there and see how it works, right? The sigmoid sigma 10h, we have 10h. Again, we have this is a forget gate. You can have here the data is there. So it can be, LSTM can be used for regression, classification, whatever you want to use, and you can have the modules. I'll just put another example and see if we can. I'll just put it here only. I'm not making another one. Random seed, you're fixing the seed so that you get the same results every time. And then you can load the data set. I'll have to load it. I think I have shared train was there, but this data set, airline passenger data set, is there or not? I'll have to see. Let me see if it is there. Train.tsv you already have, and airline passenger was there somewhere. Yeah, it is there. I have uploaded on Teams also, if I'm not wrong. All the data sets. Let me check at Teams also. It should be there. It is not, then I'll upload. It should be in the files. Okay, in files, yeah, it is there. So you have the dataset, you can download from here. Also, it is in files, so you can have a look at it. Okay, so let me have another dataset and see if this can be done better. Airline passengers.csv, can have a look. So number of passengers and the year, this is a very small data set, so it should not take much time. And we can run it and load the data. Image data sets or other data sets, sometimes they take a lot of time. So you just have to be a little careful with that. So 0 to 1 rescaling, and all we have to do, we have to see and we will print the data, data set. It is data set. Okay, this is the data set we have. Okay, now then you have to normalize that. That is what I was telling you. In the range from 0 to 1, it has to be normalized. So feature range is 0 to 1, and you have to fit the transform, the min max scalar we have called, and then you have to fit the transform to transform the data set. From this, you will see that how the data set is now. Yes, you can see that. It is now between 0 and 1. The probabilities are between 0 and 1. So we have actually converted that, and the theoretical part I've already put in there. Now look at it, and then we have to split the data set also. The ratio we have to decide. So validation set and testing set we have to see. So normally we take 10, 20, 80, 30, 70, or 30. In this case, it is 33, 67. So you have to split, and the splitting can be in different ways. You can split it simply by taking the data. Like we have found the length of the training size, and then test size minus training size, whatever the length is left, and from 0 to training size we have got the data, and training size to length of the data set we have found the other data set. So training and testing we have put like this. So you can do it this way also, or you can use the split command also. But since it is a small data set, we have done this. Okay. So now we have to use numpy and all. So you have to convert the data set again. You have to values convert into values. It's got stuck somewhere. That's okay. It is taking time. 1 minute. Mm. It's taking time to load. There is some problem with my network today. I may be switching over to the other network. Let me see if I can. This one is a little slow, so I have to see if I can switch over directly.
Excuse me, sir.
I was muted. Uh-huh. Then I wouldn't have. Anyway, I'll speak again. So no issues. I was mute. From which place I was running it, but okay. So for LSTM for regression, you can you can have a look at LSTM for regression. I'll just go up a little bit more, and from here I'll have to speak again. I didn't see the message anyway. So what I was saying was this is done. This is the model. You can see that the validation and the training loss here. It's not a very good validation loss is going up, and you can see that here also validation accuracy is going down, and training accuracy is really rising, but still. So what I was telling was that you can play around with these values. uh, LSTM dense output layers, you can experiment with the values, you can decrease them. Okay, and see how it works, and it would be little faster, and the batch size also has to be changed. Like if you're using this is actually double of what the layers we have given, 256, you can reduce that to one, maybe one or maybe eight or something like that, and see how fast it works and how good it uh, actually classifies, or what the accuracies you get. So you can experiment with these values, decrease them or increase them. Decreasing will be better because increasing will again take more time, and dropout also you can experiment with, and layers are okay, fine, that's okay. Then you can fit and check this one, this, and you can compare with this output whether your training loss and validation loss is appropriate or not. In this case it is not. There's a huge difference in this case also, accuracy also. So you'll have to experiment with some values here to get a better result and faster result, because it is taking a lot of time. It took almost an hour, and because of the speed also there was some disconnections also. It happened that it took more time than required, but anyway, it will take time. So you can see that you can reduce the number of epochs and the batch size. So if you reduce that, then it will be fast, like we have done in the next example. This is the model of LSTM input data and how the layers work. Inside you have sigmoid 10H, and the explanation is here. You have the forget gate, the input gate, and the output gate. So we have already, I think, explained what it is. And then you can see that LSTM for regression. There's a link. We can go to this link and get more details of the model. This is another example where we have used airline passenger data, but we have not used uh, the inbuilt functions of splitting the data. In this case, we are calling NumPy, Pandas, Math, then Kira's model, sequential, layers, dense, and LSTM. Then minimizer, we are calling min-max scalar, sorry, we are calling, and then for matrices, we are using mean squared error. That is the loss function we are using that. Then load the data set, which is there with you. This airline passengers.csv file is already there in Teams. You can use it from there. Okay. Then read it, and we have to convert it into float 32, and then we have to see that the data is what the data is. We need the data in between 0 and 1, so we have to use min max scalar function, which we have used down there. So I have to, yeah. Scalar is min max scalar, which we had already called from Kira's. Feature range is 0 to 1. So we have created an object of scalar, and that it has to be, and then we fit it on the data. set. Like how we fit it, scalar dot fit transform. Okay, so create an object. uh, 1 minute. Where create an object uh, for scaling the data between 0 and 1. Then you have to transform the data set. So you can see now the data set is transformed between 0 and 1. You can do it yourself also mathematically. You can divide with some value and it will come. And then we have to split the data. And in this splitting, we are not using the usual way of train test split, which we use as a model. We are just using our own method. You can see first we have to find the length. So 6733. So length of the data set into 60 into 0.67, that is divided. And then we get the length of the data set minus the train size, that is test size, and the train size. We get the train size and the test size, that is 96 and 48. So here we get the train and test size like this. Now the function you have the default the create x and y. We have to create training set and does testing set data x and data y. So we create a function called create data set, which takes data set and lock back as the parameters. Look back is sorry, not lock back, it is look back. And then we create empty list in the function. Then we iterate through the length of the data set till look back minus 1, that is 1 minus 1. Then we have the data set A and data X. We are appending to data X and appending to data Y. That is the next from the back. Look back 1 I plus look back comma 0, and that is I2 I plus look back 0. So from where we leave, we take the other part, the remaining part, that is 33% part into data y. So data x and data y we are appending row by row. We are reading each row and splitting the data and appending into data x and data y. Now, where we have to reshape x and the y, okay, as t and t plus 1. So train x, train y, create data set, train, look back, and test x, test y, create data set. We're calling it basically. And now we have the data. This is what was written here also. Then we have to reshape, and for that we have to use a numpy dot reshape 10x minus shape 0 1 and 10x dot shape 1. And then again test also has to be reshaped so that they have the same shape. Now they have the size was 94 946, 94 by 1 by 1, and this is 46 by 1 by 1. So now we will put 4 layers we have. So network has a visible layer with one input, a hidden layer, and 4 LSTM blocks. So we are having 4 LSTM blocks and an output layer that makes a single value prediction. Okay. For a single value prediction, we have a output layer, that is one output layer, and the default sigmoid function activation function is used for the LSTM block, and it is trained for 100 epochs. So model is sequential. You can see that in the how we have created the model. Model is equal to sequential. This is almost standard with every deep learning we are doing. Then model dot add LSTM4, that is 4 blocks we are adding, or neurons we are adding. We don't have neurons, we have blocks here in LSTM. So 4 blocks we are adding. Input shape is 1 to 1 because block look back is again 1. So 1 by 1 input shape. Then model.add, we're adding a dense layer, and then we have to compile. Then this we have the loss function as mean squared error, and optimizer is Adam. Then you have to fit, that is compile the model using trinx, trainy tester, and epochs as 100, and batch size as 1, and verbose as 1. I've kept the batch size low so that it can run fast. Otherwise, it will again take time. Epochs is okay, batch size I've reduced. So you can see that 100 iterations it has taken. Now we have to get the prediction. So train predict and test predict. So model.predict, model we have already trained. So model.predict train x, and model.predict train y. Test x, sorry. Train x and test x. We pass on the data, get the prediction, and for we have to calculate RMSE in this case. So for calculating the root mean square error, we have to inverse the predicted value. The train prediction we have to inverse scalar dot inverse transform, then train y. We what we get is scale dot inverse transform train y. Okay, that is what we have got the original data set, and then test predict will be scale dot inverse train transform test y, and then again test y is equal scale dot inverse transform test y. So we just inverse it, and then we have to calculate. The train score is math dot square root of mean squared error MSE train y from 0 and train predict till 0. All the elements of the first row. So you're passing on. Then we calculate the train score and the test score and just print it. So we get it. And then we can simply plot and see if they're appropriately matched. And you can see that the lines are okay. They are not going here, there. So although the accuracy doesn't look very promising, but you can see that the validation is okay. It is matching. So we have the functions here. Plot in numpy empty like until like data set we get and that is shift train prediction for plotting. Then we shift test prediction for plotting, and then we plot baseline and predictions. Okay, so we prepare the data set and then we plot it to get appropriate results. So this is another way of doing this, but LSTM is not that tough. It can be used like this, simply this way. You can use, it's very easy. All the actually machine learning and deep learning models are easy. You can just, you need a training set, testing set, and then this is the model. Something like this similar model you can use, or you can reduce the layers and see. If the data set is not big, then we don't need many layers. Let me save this first, and then I can share it with you. This will take a lot of time to practice, because uh, your this compilation will take time. When you compile the model classification, you can say it will take time. Anyway, I'll share the link. So you have a lot of work with you to complete. There's some network issue. I don't know why, but fiber optic is not working today. I'm using another Wi-Fi connection. So let's hope it works fine. My system is not taking or whatever. I'll check it later, but I'll share it with you now. It is taking a lot of time even to write, all because of network issue. I've already shared lab 7. This is 7.1. You guys can practice till then. And I was muted, I did not know. Anyway, it is scanning my network. I don't want to scan it. Time, so it could not be loaded. Let's see if it loads. I have to set some other place also. I think it's open somewhere else also. Yeah, it is there. I'll share the root folder with you. It's already there, so you don't have to do it again. You have to do some clustering algorithms, or sorry, some boosting algorithms also. We'll be doing that next week. This is coming week. I have shared here. Um, mm, okay. What is this? Uh, I've shared with you. I'm not sure how good it is going to work today. Network has a big issue. I have to fix my network and see what happened. Till then, you guys can go through it, and you have a lot of work to complete actually. So you have to do all this. Let me complete my work also. Switch again. I was on mute, but I'm not on mute now.
sir.
I have to stop the recording. It is not required now.